Now we take a look at some derivatives. For this first problem, it's asking you to use the power rule and sum and difference rules. And remember, the sum and difference rule is just using the power rule again and again. The f of x names your function. F prime of x names your derivative. And so because this says f prime of some number, we're going to find the derivative and substitute in that number. And then we're going to talk about what that actually means. Let's go down to 4 and actually find some derivatives. So when you do this guy, you're going to use the power rule. You name the derivative. The constant in front comes along for the ride, x to the 7th. You bring the 7 down, and you get 7x to the 6th. The derivative of that negative 17 is 0. So this gives you then 42x to the 6th. Let's go to one that's interesting. This one, let's rewrite it before you take the derivative. Remember, x square root of x is x to the 1/2. Now you can use the power rule on that. So I'm just going to rewrite them here on this side. On this one, we always want to rewrite it as some number times x raised to an exponent so that we can use the power rule. This is really like 5 times 1 over x to the 5th. We can use our exponent rules to make that x to the -5, and now you can use the power rule. For the next guy down, you can use, because we can't simplify this, you can go ahead and use the quotient rule. You could split this apart because this numerator is a binomial. You could say 2t over 3t minus 5 over 3t, but then you're going to simplify. You're still going to end up with a mess, so you can use the quotient rule on that one. For the next guy, this we can simplify. This is 5 times x over x to the 4th times x to the 1st. And then those x's divide out. Just the x to the 1st divide out. So that gives us then 5x to the -4. And now when you use the power rule on that, it will give you your derivative. So go over here. This is equal to 7 over 4 times x. So we're just going to take the coefficient of that, rewrite the next one, x to the -17. X by itself is 1x. Now, we haven't taken the derivative of these. We're just rewriting them so that it makes it easier to go ahead and find those derivatives. This is just a number. And for this next one, we can, for j, we can go ahead and expand that by multiplying 3x to the 1st times x to the 4th is x to the 5th, and then plus 3x, and then use the power rule on that. So when we take a look back at these solutions, the derivative of the function we had was this. Now remember again, f prime of -2 means take the -2 and put it everywhere there's an x. When you do that, you then end up with -11. And you have to interpret it. Whenever you have the derivative of value is the slope of the tangent line. And when you do it at a specific value, that's the slope of the tangent line when x is -2. It's also called the instantaneous rate of change at x is -2. Now for those derivatives, we went ahead and rewrote them. So you rewrite it like this. Over here, we rewrote it as x to the 1/2. To take the derivative, the 1/2 comes down. 1/2 minus 1 gives you -1/2. So all of these, power rule, quotient rule, power rule. This is power rule where it's just a coefficient because your original function's linear. Next guy, power rule. For f is 1 times x, and it's just the coefficient because it's the slope of a line. For the next one, h, that was f of x equals 17, and that is a horizontal line who has a slope of 0 everywhere. And so you have to be careful of the ones that have linear terms and are numbers for the original function because you get these special derivatives then.